Okay, the first part here is just a straightforward binomial. You're told that the probability of a customer buying a cup of tea is 70% or 0.7, and you take a sample of 20 customers. So if we let x equal the number who buy a cup of tea, then x has a binomial distribution where n is 20 because you've got 20 customers. Probability of success, that's buying a cup of tea, is 0.7. We want therefore the probability that x is greater than 15. Now that means we want the probability that x is 16 or 17 or 18 up to 20. So we want then 1 minus the probability of everything else. Well, everything else is going to be 15, 14, 13. So we want 1 minus the probability that x is less than or equal to 15, because that's everything else. We can then go to the tables. If you look that up in the tables, you get 1 minus the probability, 1 minus 0.7625, and that comes out as 0.2375. That should be fine. Okay, we're now told that the probability of somebody buying a chocolate muffin is 0.35, and the question says, what's the probability that Joe sells the first chocolate muffin to his 5th customer? Well, that must mean that the first 4 customers who come in do not buy a chocolate muffin, and the 5th one does. Now, the probability that somebody doesn't buy a chocolate muffin is 0.65. So that's the probability that the first person doesn't buy a chocolate muffin. We multiply it by the probability that the second one doesn't, and then the third one doesn't, and then the 4th one doesn't, but the 5th person to come into the shop is, if he does buy a chocolate muffin, that probability comes out as 0.35. So if we multiply those all together, it's slightly easier to do 0.65 to the power 4. In fact, it's just the geometric, but you don't really need to know that. Multiplied by 0.35, and that comes out as 0.0625. Okay, this is where it now starts to get a little bit harder. The question says, what's the probability, if you've got 20 customers, what's the probability that more than 15 buy a cup of tea and at least 6 buy a chocolate muffin? Well, we already know the probability out of 20 customers that more than 15 buy a cup of tea. We've just done that in part A. So the probability that x is bigger than 15, we already know, is 0.2375. We now, let's say y is equal to the number who buy a chocolate muffin. And we need to work out, because this is what the question is asking us, and we'll worry about putting the two together in a minute, the probability that at least 6 buy a chocolate muffin. So we want the probability that y at least 6 means greater than or equal to 6. In other words, 6, 7, 8, and so on. We're talking about 20 people, so y has a binomial distribution, sorry, I forgot to write that, where n is 20, 20 people are, there are 20 customers. Probability of somebody buying a chocolate muffin is 0.35. We've already been told that. So we want then, back to this, the probability that y is greater than or equal to 6, in other words 6, 7, 8, that's going to be 1 minus the probability that x is less than or equal to 5. And that comes out, we can use the tables, as 1 minus 0.2454, which is 0.7546. The question now says, find the probability that in a random sample of 20 customers, more than 15 buy a cup of tea and at least 6 buy a chocolate muffin. And essentially the question is just then saying, what's the probability that this happens and this happens? And the only thing that we need to do there is multiply the two together. So 0.2375 multiplied by 0.7546, and that is just 0.1792.